Hi, and welcome to Group Phenom. Our group consists of myself, Carla Bramlett, Jake Daniels, and Matt Winkler. Specifically for our project, we wanted to try to find a data set that had dealt with specific issues pertaining to healthcare or socioeconomic issues. Our data set was taken from the U.S. Department of Agriculture based on a survey performed in 2010. A study was conducted to determine the prevalence of Americans living in food deserts across the United States. Food deserts are defined as those individuals living at least 1 mile away from a store in urban areas and 10 miles or more in rural areas. It's also measured by the number of stores within the area as well as other socioeconomic factors. 70 nominal variables, including counts of individuals by state, as well as percentage share by state, were included. The social economic categories in the dataset include low access combined with low income, low access with presence of children, low access with presence of seniors, and low access with or without access to a vehicle. All food access variables were measured at several distances, including half-mile interval, 1 mile interval, 10-mile, and 20-mile intervals as well. For our M1 models, we took several different approaches. Two of the models specifically utilized PCA, and the third model used PCA combined with LDA. The first version of the model, which was mine, I looked at 20 variables that consisted of all distance ranges and corresponding socioeconomic categories. These variables specifically looked at the counts of individuals by state rather than the percentage share. The results of my model showed that I was able to extract 6 components that cumulatively accounted for 90% of the variance.
For my first model, I ran a principal component analysis. I used 10 variables from the original data, which were low access population, low income kids, seniors, and vehicle access for both half-mile and 1 mile radius. With these variables, I used a PCA to extract new features and created 10 principal components. Out of the 10 components, only 3 are needed to account for 92% of the variability in the data. Looking at the loadings for the first 3 components, I'm able to see which variables contribute to the components. Component 1 was influenced slightly by every variable, which makes it difficult to interpret. The second component has great contributions from the variables of low income and vehicle access within a half-mile. This means that component 2 could indicate rural areas, since people with low income but have a vehicle are more likely to live in a rural area where there is less public transportation. The third component was influenced negatively by the variables that are at a half a mile and is also influenced positively by the variables that are at a mile. This can mean that component 3 describes distance.
So my name is Matt Winkler, and for my first model, I used PCA as a precursor to an LDA approach with the goal of trying to classify urban and rural areas in the state of Kansas. So when I used PCA as a first step, I did that to remove some of the collinearity that we saw in the initial data and also reduce its dimensionality. I ended up extracting 3 principal components from that PCA analysis. They appeared to be strongly influenced by areas with low income, high proportion of rental units, and distance also emerged as a key factor, mostly because I saw some different results depending on which distance radius I used as an input into the PCA. Once I took those principal components and put them into an LDA model, again, my goal was to classify the areas that were designated as low access to supermarkets from the state of Kansas, and then bucket them into urban and rural categories. And in terms of accuracy, I got the results shown in the confusion matrix in the middle of the slide, where for rural areas I was able to predict with 70% accuracy, and urban I was able to predict with 74% accuracy. I thought that the results were decent, not spectacular, but I did also kind of take away that the the distance input was kind of a key factor for some of the further modeling that we did down the road. And I also wanted to find a way to kind of classify these census tracts within more detail beyond just urban and rural splitting, so that we could point to some more like socioeconomic or marketing type of opportunities.
For our M2 models, we utilize PCA with LDA. We also use PCA with k-means clustering and k-means clustering without the use of PCA. The first M2 model, which was mine again, I decided to utilize the 6 components that were extracted from PCA and perform k-means clustering on those components. Prior to performing the k-means clustering, I normalized those components by using standard deviation and the means. I also utilized a scree plot to assess the initial starting point for K for cluster analysis. Given that there were a total of 6 components, I started my cluster analysis with 5 clusters, which resulted in a 38% sum of square error, and the second iteration for 6 clusters resulted in a 50.5 sum of square error. With the second iteration, it resulted in roughly a 22% increase. However, it wasn't quite the result that I had expected. One of the difficulties that I had with this model is the ability to interpret or really understand how the clustering was being performed when using the PCA components, given that they were feature extractions, so they're in some respects a new version of the features from the original data set, but representing the same features but yet a somewhat new version. So I don't think the model results, I didn't quite get what I had anticipated there with this particular model.
With my second model, I chose to run a linear discriminant analysis on the 3 components that I extracted from my previous PCA. I wanted to look at how well these new extracted features were in predicting if a tract was in a rural area or an urban area. In my confusion matrix, you can see that I was accurately able to predict 92% of the urban tracts correctly and 65% of the rural tracts correctly. With the number of rural tracts being far less than the urban areas, this makes the accuracy for the rural area more important. And with only a 65% accuracy, this model does not seem to be in high quality.
So for my version of the M2 model, I used a clustering approach, and I kind of took from the insights that Carla found with from her version, which combined PCA with clustering. I kind of got the idea that maybe we should try to cluster, but do so on the initial variable inputs, and because by substituting the initial data, the interpretation would become a little more clear. So when I did that, I ended up identifying 3 clusters where there are potential marketing opportunities. So those are numbers 5, 6, and 7 in the chart. So number 5, we kind of intuited from the clustering output that those areas are kind of they're low access areas, and they also are lacking in vehicle access at half a mile. So kind of given that and they're also a low income. So those are some folks who are they don't have a grocery store close, and they're also unable to kind of maybe go somewhere else to find a grocery store. So that combined with the low income made us suggest that Aldi might be an appropriate store to locate in one of those areas. Cluster 6 was a high income area with a dense population. And it also appeared that while there were a significant number of individuals with low access to supermarkets, vehicle access wasn't also a problem. So we'd suggest kind of a differentiated approach, something like Whole Foods catering to those high income folks. Cluster 7 had a decent number of people showing low excess at the half-mile radius, but not at the longer radius. And they also had they were also not especially, they were pretty average in terms of income, maybe a little bit below average. So we'd think that something like a Joule or similar might make sense in that type of a zone.
In conclusion for our project, based on the various models we conducted, the following are some of the key conclusions we were able to come up with. While PCA was successful in extracting and reducing the overall number of features, the components when utilized in clustering and LDA made interpretation a bit more difficult. The variable of distance in general was a key factor in both clustering and LDA specifically. Constraints of the variable types and the data set possibly indicate it is not best suited for k-means clustering when utilizing components from PCA. We required several iterations of all of the models to identify the best possible combination of variables for both PCA and LDA. And again, overall, our thoughts and findings here is because of the limitations of the types of variables that we had, there was very little demographic information, and they were all in some respects of the same type, with the only difference being either the distance radiance or the social economic category. There was not a lot of variety in terms of the variables that we actually had in the data set. Follow-up opportunities, we would like to include an experiment with adding in more robust demographic information appended by census tract and state as an additional data set to, again, provide a little bit more information to this data set and see if we could extract different results in terms of PCA. How do those components look? And then again, what is the net impact to utilizing LDA as well as clustering? Thank you.